Hello guys, good evening. I'll be doing basic Galelian and Lorentz transformations. I'll be deriving something called the gamma term, which is also known as the Lorentz factor. So today I will show you two core equations that govern basic um, relativity. So we start with physics is all about thought experiment. So we're going to do a little bit of experiments or imagination, and then we write those imagination the constraints in our imagination as variables so we can make an equation out of it. So let's say we have two systems or 2 points in space. Oh, let me not just point in space. Two systems is a more better terminology to use. Say this point is xc and this is xm, location xm. This point, so let's say it's a car and the two people, one is standing here and the other is standing here, and this one is moving at the velocity v. Let's say 15 meters per second for xm. So we want to find how, because according to this guy, this is basic Galilean concepts. If he wants to measure the position of this guy, because according to what Einstein said in his two theorems of relativity, the first one is that the the laws of physics are the same for all observers. So according to this guy, he's going to argue, or she's going to argue, that the rest of the world is moving away from her at this speed, 15 meters per second, while this other guy or this other girl is going to be arguing that this x sub m is moving away from the universe at 15 meters per second. So how do we technically relativity is about reconciling people's arguments, and then for them to agree on the same thing, because according to this guy, the laws of physics are constant. Everything that happens to him obeys the laws of physics, and this guy also, or this girl also, argues that the laws of physics don't change. That means she's not the one, or he's not the one moving. So who's right and who's wrong? So relativity is just about reconciling these two egomaniacs. So let's say we are outside the universe. This has to do with something called Mach's principle. Say we can determine who is moving and who's not moving, and we know that this girl or this guy is moving at this speed and this one is staying in one position, but he or she doesn't know. But I'll talk about this later. It's called Mach's principle, how the very big affects the very small, and so on and so forth. So it has to do with some things called centrifugal and centripetal forces. So according to this guy, he's going to measure his or her position to be the rate, the product between the velocity of whatever speed he's using or she's using, in this case 15 meters per second, multiplied as a product of the velocity and the time it takes the person to reach a particular location. So that is what he's going to measure. So this guy x sub c, the marker is bad, is going to measure a velocity to be v times c. But now we're not dealing with three spatial dimensions, so we're going to remove the vector sign and just say x sub c is equal to velocity times time, because this m, according to c, is going to be velocity times time. X sub m, and let me just put this by the way, because normally we have that velocity is equal to distance divided by time, or displacement, but in this case it's linear displacement, so linear velocity. So linear speed is the same thing as linear velocity. They have the same. There is no vector notation. So v is equal to distance divided by time, dealing with one spatial dimension, or straight line, or something like that. So the distance covered by x sub m is equal to the product of velocity and time. This is basic mechanics. So this is the distance as measured by c. So c, x sub c will measure a distance. This is x sub m, which is the position of this guy or this girl. So as measured by x sub c, this is a correct axiom, or a correct axiom. So according to this guy, he might not agree on what x sub c is measuring, or this girl, he might not agree what x sub c is measuring. So he or she is going to argue that at any point in time, or any duration in time, her position as measured by her is simply just x sub m. So in order to reconcile these two guys, Galelian transformation simply says we add the position as measured by x sub m and the position as measured by x sub c. The position measured by x sub c is x sub m equal to velocity times time. So we say that x sub c will be the addition of x sub m and what he measured before, velocity and time. This is the simplest version of Galilian transformation. So Galilian transformation is x sub c, which is the primed observer, measures the position of the unprimed observer, which is given by the product of velocity and time, plus the argued position of the unprimed observer. So in physics, we just write it as x prime. X sub c is the stationary one. X prime is equal to x plus vt. And then how do we determine time? According to the early versions of science, argued that time is absolute. So whatever time he measured or she measures will be the same time. Let's just use this. Will be the same time that he or she measures. So according to Galileo, t prime, whatever time he or she measures at the same time that he or she measures, is equal to t. But then I want to show you what Hendrik Lorentz said. I'm not going to derive it, I'm just going to write the equations for you. He introduced something called the gamma term. The gamma term, Lorentz gamma. Do not mind my handwriting. That's a very ugly gamma. Yep, is given by 1 divided by the square root of 1 minus the quantity, or which is the squared ratio of the velocity of an object divided by the speed of light. So he introduced something called the gamma term. So according to Lorentz transform, this is Galelian transform. These are the two core equations. According to Lorentz transform, he said that x prime, which is the velocity, the position measured by the primed observer, is equal to this gamma term, which is 1 divided by the square root of 1 minus v over c all squared. So gamma times x prime, this is x prime, plus vt. This is gamma, by the way. So x prime is equal to the gamma term into bracket x plus v times time. While time isn't absolute, as we all know, is equal to gamma into bracket t plus v over c times x. So I'm going to show you, this is just what Lorentz is trying to say. Time isn't absolute. This is what Galileo thought. He and Newton thought the same thing. The time was absolute. So yeah, Lorentz, this equation is telling us that time isn't absolute. It's not the same for everyone. While this is telling us the time is the same, which was what Galileo and Isaac Newton thought of time to be. So now I'll be wait a second. I want to derive the gamma term for you guys. So what is the gamma term? As I said before, the gamma term is given by